standard component blues got you down? Getting bogged down by limited off-the-shelf components? Feeling low because your connectors just aren't delivering the flexibility you want for your next design? Yeah, join the club. Hi, I'm Amelia Dalton, host of Chalk Talk. Did you know that you can create custom modular connector solutions from off-the-shelf components that are robust, save PCB space, and are easy to assemble? Oh yes, you can. My guests today are Phill and Nazario Biala from HARTING, and they are bringing us the goods on the Har-Modular PCB connector system that gives you over 1 billion combination possibilities for data, signal, and power. And if we're going to get to 1 billion, we better get started. But before we get going, don't forget to click that link. There you can find even more information about the Har-Modular PCB connector system from HARTING. Hi, Phill. Thank you so much for joining me.
Hi, Amelia. Thanks for having us.
And hi, Nazario. Thank you for joining me.
Hi, Amelia. Pleasure to be here.
Excellent. Okay, Nazario, we are talking about Har-Modular today. But before we get started, can you give me some background on HARTING?
I sure can, Amelia. Founded in 1945 by Wilhelm and Marie Harting, HARTING is still 100% family-owned company with over 5,000 employees and 44 worldwide sales locations, and is a global leader supplying connectivity solutions not only for data but also for signals and power. And as a global company, HARTING has 14 manufacturing plants located in North America, Europe, and Asia to serve its global customers.
Excellent. So, Nazario, what kind of issues are we looking to solve today?
Amelia, as an industry segment manager, I get a lot of opportunities to talk with automation engineers to discuss their design challenges and needs. And what I've learned is that engineers are looking to making their devices smaller, more robust, more modular, and have more functionalities to improve serviceability. Because as you and I both know, at the end of the day, the end game is to increase productivity. So knowing that, as a company, where these top-of-mind issues are always at the forefront for us, especially when developing new products and new solutions for the market.
That makes sense. Now, Nazario, another important element here is how we can shorten our overall development time, right?
That's correct. Modularity and flexibility are becoming increasingly important in equipment development today. And the development times of new devices are becoming shorter and shorter, and prototyping is playing an increasingly important role. The challenge today, however, is that a limited selection of available standard components is often an obstacle in device development. The solution to this challenge is modularity, flexibility, and more speed in device development, and this is where the Har-Modular shines. Now, Phill will go into details on what the Har-Modular solution is all about, so I'm not going to steal his thunder, but suffice it to say, it's a modular connector that allows engineers to mix and match various combinations of signals and power in one connector design, providing engineers ultimate design flexibility.
Very cool. Now, Nazario, in your work at HARTING, do you have an example of this kind of solution?
Amelia, we do. In keeping with the miniaturization trend, one of our key customers was tasked with developing a new servo drive platform with the mindset of having a smaller footprint and more functionalities. A key aspect of their design that they wanted to focus on was to combine their power and signal transmission with one connector to save on board space. Our customer developed several prototypes to determine the best power and signal combination design, and this is where our Har-Modular played an important role in helping them achieve this. As a user configurable modular PCB connectivity solution, the Har-Modular provided our customer unlimited freedom to help them realize their optimal board design. And it is this design flexibility that helped the Har-Modular garner the German Innovation Award 2021 in the gold category, which is the highest distinction the jury bestows in connection with this award.
Fantastic. All right, so let's get into the details of Har-Modular. So what all will we be covering today?
So we're going to take a look at this new Har-Modular product. So firstly, let's explain what it is, and then we'll go into more detail of which modules are available and how they're assembled. This will include a short video in which we'll see modules being put together to create a connector. Then we'll use the configurator, and this is a really very valuable tool. It allows the customer a very easy selection of the modules and it also provides all the necessary data, such as the technical specs and the drawings. And again, this will include a short video to give us a clear view of how to use the configurator. So let's begin by answering the question, what is HarModular? So this is a new PCB connector range, which has evolved from traditional DIN 41612 connectors. In the picture on the top right, you can see an assembled connector consisting in this case of 6 modules. And then below that, you can see a picture with those same modules prior to assembly. And by having these modules available off the shelf, our customers can choose what they need and then assemble them into their own custom solution. And really this starts to go into the detail that we got from Nazario. It's bringing benefits of space saving, processing efficiency. By having these modules available off the shelf, our customers can choose what they need and then assemble their own custom solution. And this can bring benefits of space saving, processing efficiency, as one connector can now take the place of multiple connectors on the PCB. And as we'll see a little later in the video, assembly is easy. Everything's locked together with these fixing rails that you can see at the bottom of the slide.
Excellent. Now, Phill, what kind of features are included in HarModular?
Okay, let's re-summarize those features and add a few more. They're modular PCB connectors. As mentioned, they're easy to assemble, and it's done also without any expensive tooling. And again, these modules allow customers to assemble their own connectors, no lead time, and there's no cost for us as the manufacturer to tool up new connectors in our production facilities. As we will see, there are a variety of modules that can be configured together to deliver a hybrid connector, and potentially that's going to reduce the number of connectors on the board. Because the contacts used in the modules are the same as the contacts from our traditional DIN 41612 range, we're delivering genuinely tried and tested, robust and durable solutions. Now that DIN connector range has been around for more than 40 years and is used in a wide variety of applications. So now that durability is available in custom connectors. And as we'll see later, the configurator makes product selection very easy. Now there's no industry standard for HarModular, it's a new product. And as we're using the contacts from the DIN 41612 range, we've conducted type tests according to the IEC 60603-2. Now that's the specification for DIN 41612 connectors. We chose to test to the performance level 1 specification, and that guarantees customers a minimum of 500 mating cycles. Additionally, to ensure compatibility with high temperature reflow soldering processes, we use high temperature plastics, and therefore HarModular can be used on surface mount boards as a through-hole connector.
Okay, so Phill, can we take a closer look at the connectors of HarModular?
Yeah, let's introduce the modules before we then go in a bit more detail on each one. On this slide on the left, we can see the individual modules, and on the right, we can see an assembled connector. Starting with number 1, we always recommend the inclusion of guide pins and receptacles. The example shown here is a plastic guide pin, and as we'll see later on, we also offer a metal guide pin. The second module here, this is actually a 40 amp module, and this uses a single cavity plastic module which can take a variety of other contacts, but in this case we're showing an example of a 40 amp contact. With number 3, we can see a 3-pin module with blade contacts, and each one of these blades can carry 15 amps. Then we have a 4-pin module, they can carry 6 amps. And finally, we have a 9-pin signal module, and those can carry 2 amps. So now, to take that into how this works, these each have a designation for when we talk about the individual modules. So following the same sequence, we start with T for the guide pins and receptacles, M1 is the single contact module, H3 for the 3-pin connector, F4 for the 4-pin, and C9 for the 9-pin. Now there are a couple more topics that we're not going to have time to discuss in detail. Just to let you know, we have dummy modules. So there's actually a blank position in the connector. Those are available. And with all these combinations, it's also possible to code individual connectors. So in the event that similar configurations are chosen by the customer and they're used in the same application, there's no risk of mismating similar connectors.
Okay, so Phill, earlier you mentioned we'd be getting into the modules and assembly of HarModular. Can we start with the signal modules? What are we really looking at here?
Sure, let's take you through that. So starting with signal modules, here we have what we call those C9 modules. As you can see, we have straight and right-angled male connectors, along with straight female connectors. This module is 10.16 millimeters wide, and as we go through the modules, you'll see different widths, starting with the smallest at 5.08 millimeters. These are all offered with solder termination. And for the male connectors, we can also offer leading and lagging pins for sequential mating of the two connectors.
Okay, so Phill, what about the power modules?
Yeah, the power modules, as you said, that's called the F4. And here we have the same orientations and the same solder termination as the C9. Again, these are the same size at 10.16 millimeters. And once more, we have some leading and lagging pin options available for the male connector.
Okay, so Phill, what if I only need 3 power contacts? Do you guys have a different signal module in that case?
So there isn't a different signal module. We could deliver a signal module with fewer contacts if required, but we do have another power module which would be the H3, and this is the one with the blade contacts. This will carry 15 amps. And in this case, the modules follow all the same information we saw before in terms of orientation and termination. But now we're looking at a module that's twice the size at 20.32 millimeters.
Okay, so I'm also interested in that M1 module you mentioned earlier. What kind of features does that one contain?
Yes, this one's a little bit different. We take a slightly different approach here. These are all delivered as empty modules. Before we saw connectors that are delivered with contacts fitted. For any customers familiar with our DIN 41612 type M connectors, this is the same arrangement where the special contacts, as we call them, are fitted by the customer. Now, those special contacts can include a variety of power contacts, coaxial contacts, and even fiber optics. Unlike the other modules, these can accommodate both board-mounted contacts and also cable-mounted contacts. And in total, there are more than 30 different contacts available to use in the M1 module.
Wow, okay. So, Phill, we also need to think about guide pins here as well, right? What are our options here?
Yeah, so we started out by mentioning the guide pin when we were showing the assembly, and this is important. So we can show you here that we have both plastic and metal guide pins. Obviously, the metal would be a little bit more robust. Different widths, 5.08 millimeters and 10.16 for the metal. And this includes both the guide pins and the corresponding receptacles that would fit the guide pins.
Okay, so for these kinds of modules, we need to consider that finishing rail, right? What does that look like with HarModular?
Right, so here we go. This is the fixing rail that really holds everything together. So each connector will be assembled with both a top and bottom rail, and you'll see this very clearly in the assembly video. Now, these plastic rails have hollows every 2.54 millimeter along the length, and these correspond to a toe ball on each connector. The rails have a dovetail design which snaps into place, and then the ball and hollow arrangement will hold everything in place. With this secure design, everything's properly aligned and all the tolerances are controlled. Now, we talked about the modules having different widths, and of course there are also many different combinations of modules. So consequently, we need many different lengths of locking rails. And the good news here is that when we get to the online configurator, we'll see how when that's used, it automatically selects the correct length of locking rail for the selected modules. So there's no need for anyone to calculate what length of rails are required for what combination. It's pre-selected. Also point out here that these rails allow for the connectors to be reworked if, for example, the customer wants to swap two modules out. And this can be done by pulling out one module from the end and then actually levering the rails out before reassembling. So let's go ahead now with the video and we'll show you the assembly steps. We're going to see an example of a male angled connector with two C9 modules, one H3 module, one M1 module fitted with a power contact, and also the guide receptacles. Starting with a simple plastic alignment tool, each module is put in the desired position, starting and finishing with guide receptacles. Then with all modules closely placed together, the fixing rails are added. And finally, that separate power contact is fitted. So there we are, create your own. Here we have an assembled male connector. The process is the same for the females. It just uses a different alignment tool.
So, Phill, what do you think this solution buys me as an engineer in this case?
It buys us that custom off-the-shelf solution. So if we take another step, we've shown how to create the connector, but let's now think about the real world and how that connector may go from prototype through development and finally into production. So again, we've established that the engineer can have off-the-shelf custom connectors, and they can assemble, they can reconfigure, and all of that's done without setup costs and lead times. There'll be a point that the assembling may actually become impractical for production volumes. It's gone beyond the engineering stage, it's now into purchasing and production. The good news here is, in this case, Harting can deliver assembled connectors so that the customer receives a single part number made up of whatever modules were selected. And we can do this for volumes as low as 200 pieces, and we can do it with short lead times. So from design right through to production, we're offering maximum flexibility and easy availability.
Excellent. So, Phill, let's talk about the configuration of the HarModular. Can you help me with this aspect of my design as well?
Yeah, right. This is key. Let's talk about the configurator. With a variety of modules, contacts, and fixing rails available, selection of the components could be quite tricky, and this is why we have this online configurator that makes this process very simple. Let's start with where to find the configurator. Looking at the Harting USA website, we can see in the top right there's a link to the configurator. In fact, it takes you to a range of configurators, and within that area you'll find the HarModular configurator. So at this point, I'm going to jump ahead to show an example of the results that you would get when you've configured a connector, and then we'll run the video to show how to do the configuration in order to reach that point. So here is a screenshot showing a mated pair of male and female connectors. We can see the part numbers for the male connectors, and there are links to take you to all of the technical information. Now, if we could scroll down the screenshot, we would actually see the female modules as well, but we'll just stick with the males for the moment. One of the great features of the configurator is that once you define the modules for one side, for example, the male, it will pre-select the possible modules that can be used in the female. So it's really streamlined. Once you've chosen one side, it helps you to pre-select the other side. So let's take a look at the video. So as you can see, this really makes selection easy. You get an instant 3D view of the mated connectors and a full packet of all the technical information.
All right, Nazario, let's talk about applications. What kind of applications do you guys see the HarModular playing an important role in?
Not surprisingly, Amelia, typical applications are similar to where we see DIN connectors used. For example, in the railway market, it can be used on rolling stock as well as besides the track and in signal cabins. And in the machinery segment, it can be used in control boxes for signal, power, as well as processes. And in the robotic market, it can be used inside the control boxes too. And then in the automation market, it can be used in control cabinets. And lastly, in the PGTD energy market, it can be used in control cabinets as well as in power supplies.
Excellent. Now, can we take a closer look at how this is all put together, especially when it comes to the backplane?
Yeah, sure. So with the available options of male and female connectors, we can take a look at how the product can be used, and we'll start, as you asked, with the backplane and the daughter card arrangement. We can see this set up here using the C9 modules, so the signal modules we talked about. We have the angled male connector fitting on the daughter card, and of course the straight female would correspondingly be on the backplane. So we can see on the left here how those look before mating, and then on the right hand side we can see them in the fully mated condition. Of course, the good news here is everything in terms of mating dimensions and mating conditions is the same as the established DIN 41612 connector family. Let's now look at the mezzanine arrangement. And so here we're going to actually use the straight males and the straight females. Again, we'll use our C9 connector as an example. Once again, on the left-hand side, we can see them in the pre-mated condition, and the right-hand side, the mated condition with a stack height from 16.8 to 18.6 millimeters. And of course, again, conditions are in line with the DIN family.
Okay, so Phill, what kind of further plans do you guys have on the roadmap for HarModular?
Okay, so everything we've seen so far is available today, but of course we're already planning our new developments. And I have 3 very quick slides, just some outline views on this as we develop these new solutions. So we are developing data modules. These will have up to 8 data lines and will be able to operate at greater than 10 gigabits per second speed. For our mezzanine applications, we're going to be offering double row configurations. So here we see pairs of connectors mounted together. And then finally, we've talked about these being PCB connectors, but we are already planning cable connectors, which will add in use for cable to board applications. This will include crimp termination connectors and the corresponding shell housings.
Excellent. Well, Phill, I think this is about all I have time for today. Can you recap your main points for me?
Yeah, let's give it a try. We've covered a lot of ground. So HarModular comes with the tagline, create your own. Clearly, we're looking to give that service to customers to build their own connectors. It is a unique solution in the market today. It's offering our customers diversity through this modular design. And as Nazario has mentioned already, this is an original design, and it's already won an innovation award in Germany. We've seen it carries over from the DIN 41612 family, and therefore it's guaranteeing a robust design, and that in turn is backed by the testing that we've done. By configuring to customers' specific requirements, HarModular offers benefits of space saving and efficiency by delivering a solution tailored for the application. So in summary, it's readily available, it's easy to configure, it's easy to assemble, custom connectors from off-the-shelf components.
Excellent. Well, I think that is all I have time for today. Thank you so much for joining me, Phill.
Thank you very much.
And thank you for joining me, Nazario.
Thank you so much, Amelia.
And before we go, don't forget to click that link. There you can find even more information about this topic from HARTING. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.